am honored to introduce the work of the Lab of Machine Learning and Data Mining of the Department of Intelligence and Computing of Tianjin University, published in TPAMI' 2025, BackMix, Regularizing Open Set Recognition by Removing Underlying Fore-Background Priors. This paper innovatively explores the impact of hidden foreground-background associations on the model and proposes a general data enhancement method, BackMix. BackMix can be seamlessly combined with other existing methods in tasks including image and video classification, object detection, content understanding, image segmentation, etc. In addition, BackMix has a painless point increase effect in many tasks, and the AUROC indicator is improved by up to 23.6%. Conventional computer vision tasks are mostly performed in closed scenes, such as image classification and object detection. The model only needs to identify known categories in the training set, and the task is relatively simple. For example, the model can well complete the classification task by distinguishing cats, dogs, and rabbits in the training set. However, the real world is open, and new categories will inevitably appear, which brings huge challenges to traditional computer vision models. When applied in open scenes, the model will encounter categories that have not been seen during training, such as tigers and foxes. The closed scene model cannot effectively cope with the complexity of such open scenes. Classifying unknown classes such as tigers and foxes into similar known classes obviously cannot meet the needs of reliable application of models in open scenes. The ability to identify the unknown is crucial for safety-critical applications such as unmanned driving and medical diagnosis, and can effectively avoid risks in real applications. For large models, making it clear what is not yet known can help reduce hallucinations and improve the reliability of the model. The open set recognition task is designed to handle open and non-fixed scenes in the real world. When facing unknown samples, the model needs to accurately identify them as unknown, rather than mistakenly classifying them as known categories. This is of great significance for improving the generalization ability and adaptability of the model in complex environments. At present, the methods of open set recognition are mainly divided into three categories. The discriminant method designs a classification strategy for the open set recognition task to enhance the model representation learning ability. The generative method uses the generation module to generate distribution fitting known classes. The auxiliary data-based method realizes outlier exposure to regularize the model. Among them, the discriminative method has weak performance, the generative method has high training cost, and the quality of synthesized samples is unstable. Although the auxiliary data-based method can effectively improve the model's ability to recognize unknown samples, it requires careful selection of auxiliary data, which introduces the overhead of collecting and screening data. Therefore, can we regularize the open set recognition model without carefully selecting auxiliary data? In natural images, the foreground is usually related to the category, and the same foreground does not affect the classification result when it appears in different backgrounds. The prior relationship between the background and the foreground can be used as auxiliary context information for foreground classification. For example, cars are usually on the road, not in the water. Fish are in the water and can hardly be seen on land. So can the foreground-background relationship be used for image classification in open scenes? Studies have shown that some visual models can even achieve accurate classification when most of the image foreground is covered, but when the original background is replaced, the model will have a high probability of misjudgment. Therefore, the premise of using foreground-background prior to identify object categories is that the test and training distributions are consistent. However, in open scenes, we cannot make assumptions about the situation during testing, which shows that using foreground-background prior to identify objects is not suitable for open scene tasks. So will the inherent foreground-background prior in the dataset have a negative impact on the model? In the open set recognition task, the use of foreground-background association prior classification may cause the model to misjudge when unknown objects appear in known backgrounds or known objects appear in unknown backgrounds. For example, airplanes in the training set usually appear in the sky background. If airplanes in the test set appear in the land background, the model may misjudge due to the unknown background. This shows that in the open set recognition task, the model's excessive reliance on the background will lead to a decrease in its robustness in the face of background changes and fail to accurately identify known categories. However, existing open set recognition methods all jointly model the foreground and background of the image, and have not yet deeply studied the impact of the foreground-background association prior on the performance of open set recognition. As a potential auxiliary information, the background may play an important role in improving the performance of the open set recognition model. Therefore, it is necessary to explore an effective background regularization method to improve the performance of the open set recognition model. To explore the impact of the background-foreground association prior, we generated 4 training datasets by using the original image, erasing the background, replacing the background of the image with other original images, and replacing the background of the image with the background of other images. The model was tested in the open set recognition setting, and it was found that the model trained on the dataset with background swapping and avoiding multiple foregrounds performed best. Among them, the model trained with only the foreground image cannot distinguish the test image with the background, while the model trained with the original image has a degraded ability to distinguish the image after the background is swapped. Comparing settings 3 and 4, we find that the image that avoids multiple foregrounds in a single image has higher closed-set classification accuracy. This indicates that non-uniform background may mislead the OpenSet classifier because the model may over-rely on background information for classification and ignore the importance of foreground features. In order to reduce the misleading of the background to the OpenSet classifier, it is necessary to eliminate the foreground-background association prior in the training set so that the model pays more attention to the foreground features, thereby improving its classification performance in open scenes. Since directly learning the original image will cause the model to be affected by the foreground-background association prior in the training set, and directly erasing the background will reduce the robustness of the model, the background distribution of the training data can be changed to make the background appear evenly between categories to eliminate the influence of this prior on the model. To verify this idea, we first use the commonly used global average pooling operation to decompose the image features into foreground features and background features. Considering the characteristics of the open set recognition task, we believe that the following 2 characteristics should be guaranteed. 1. The image foreground features and background features are independent of each other for the model. 2. The image background does not affect the prediction of the model, that is, the background features are independent of the label. Therefore, we derive the following 2 theorems. Theorem 1. The mutual information maximization objective between image features and class labels is decomposed into the following formula, which should maximize the classification objective and minimize the regularization term. Theorem 2. The regularization term can be optimized to 0 when one of the following 2 situations holds. A. Constant value solution. The background feature is a constant value. B. Orthogonal subspace solution. The foreground feature and the background feature come from different feature subspaces. To verify the correctness of the theorem and the availability of gap, a variety of settings are constructed for experiments, including following the OE setting, concatenating the known data and auxiliary data, and concatenating the known data and auxiliary data separately. The indicator FT-AUROC indicates whether a constant value solution is found, and FT-COS indicates whether an orthogonal subspace solution is found, thereby improving the performance of the model. Based on the experimental results, we found that GAP has the ability to make full use of the background as unknown data for regularization, which is comparable to OE. Furthermore, we followed the setting of OE and conducted experiments by changing the auxiliary dataset used in training. The results show that the gain of the OE method on the model is strongly correlated with the quality of the selected auxiliary dataset, and may have a negative impact on the closed-set classification ability of the model. However, the background regularization method does not require additional auxiliary datasets. It only needs to process the background of the training data to achieve effective regularization of the model and improve its performance in the open set recognition task. Based on the above analysis, we proposed BackMix. The core idea of the BackMix method is to mix the foreground of the image with the background of different images to generate new training samples. Specifically, for the target classification map, a random image is selected to provide the background, and then the foreground of the background image is erased to avoid the situation of multiple classification subjects in a single image. Finally, the processed background image is partially pasted onto the target image to achieve background regularization. In this way, the model is exposed to more diverse foreground-background combinations during training, thereby eliminating the influence of the foreground-background association prior and improving its classification performance in open scenes. In order to achieve foreground segmentation while using gap regularization, we performed an equivalent transformation of the model structure with equal parameters. The original model structure is gap, linear, softmax, and the changed 1x1 convolution, gap, softmax. The feature map obtained after 1x1 convolution can be used as an estimate of the foreground part. Therefore, BackMix does not require complex segmentation annotation and additional overhead. This optimization of the model structure not only achieves the goal of background regularization, but also provides the model with the ability of foreground segmentation, further improving the performance and practicality of the model. BackMix achieves effective regularization of the model through a simple background replacement operation, improving the model's ability to recognize unknown samples. In addition, BackMix can be integrated into almost all existing methods as a data augmentation method. We conducted unknown detection experiments on multiple datasets and recorded the results using the AUROC indicator. The experimental results show that by eliminating the background prior, BackMix effectively enhances the unknown detection capabilities of multiple methods. We use CIFAR 10 as the in-distribution dataset, CIFAR 100 as the near-distribution out-of-distribution dataset, and SVHN as the far-distribution out-of-distribution dataset for out-of-distribution detection experiments. Experimental results show that BackMix enables the model to accurately distinguish between near-distribution and far-distribution datasets. BackMix is compared with other data augmentation methods in the open set recognition setting. Experimental results show that BackMix is more suitable for open set recognition tasks than other data augmentation methods, and can enhance both closed and open set indicators. We applied BackMix in the fine-tuning stage of the CLIP model and found that it can improve model performance with limited samples. At the same time, applying BackMix as data augmentation training in the pre-training stage can enable the model to have better migration capabilities and perform better on different downstream visual tasks. As training progresses, BackMix's estimation of the foreground will gradually become more accurate, ensuring the accuracy of foreground masking in background images. BackMix can retain most of the foreground in the target image while achieving background regularization, avoiding confusing the model. We investigate classifier behavior in modeling backgrounds and the impact of fore-background correlation priors on open set recognition performance. From a novel perspective of fore-background associations, results show foreground-background priors harm open set performance. Their removal boosts accuracy, and class-independent backgrounds act as auxiliary outliers. Inspired by these findings, we propose BackMix, a novel approach that generates new training samples by mixing image foregrounds with backgrounds from different images. Requiring neither segmentation labels nor prior knowledge, BackMix is implementation efficient and can be seamlessly integrated into nearly all existing open set recognition methods. Extensive experimental results validate its effectiveness. Our paper and code are both open to the public, and we welcome your communication and sharing. Thank you.